Chapter 3, Section 1, Matter and Energy. In this section, our learning goal is to classify examples of matter as pure substances or mixtures, and to learn a little bit more about atoms and elements compounds. Now, matter is anything that has mass and occupies space. It makes up all the things we use, such as water, wood, plastic bags, etc. We can also classify matter according to its composition. Pure substances have a fixed or definite composition. We'll give some examples. Whereas mixtures contain two or more different substances that are physically mixed but not chemically combined. And so when we look at this, here's our flow chart here, matter. Pure substances are mixtures, and in our pure substances, examples would be elements and compounds, elements like copper and compounds like water. Whereas mixtures are separated into whether it's homogeneous or heterogeneous, meaning, so on a heterogeneous we can see some different items in here. They're not blended really well, whereas our homogeneous, on brass, even though copper and zinc make up brass, the brass appears to all be one item. So that's kind of a way to do it. That'll get you right 95% of the time, or 100% of the time in my class. So here we go. A pure substance is classified as a type of matter with a fixed or definite composition. So it's an element that's composed of one type of atom. It's a compound that's composed of two or more elements, always combined in the exact same proportion. So, for example, an aluminum can consists of many atoms of aluminum. You could have a compound also. All right? Now then, let's go back to elements. Elements are pure substances that only contain one type of material. For example, copper is an example of an element. If you look on the periodic table of elements, which are all elements, and we'll be looking at the periodic table of elements in sections later on, but copper. So you'll notice also how we write copper. It is two letters. Now then, we don't always write atoms with two letters. It just depends on what type of element and everything. So that's a whole nother story. But I just want to point out that if it's one element, and if it's more than one letter, if it's two letters, we have a capital C and a little letter next to it if it's going to be more than one letter. So here we have lead, big P, little b. Aluminum, big A, little l. So again, another story for another section, but we might as well start getting that now. Now then, so there are examples of pure substances that only consist of one type of metal. Now, compounds consist of two or more elements that are chemically combined in a definite ratio, such as hydrogen peroxide. There's 2 hydrogens for every 2 oxygens. Or salt, table salt, sodium chloride. Or sugar, C12H22O11. Or water, H2O. They are a definite ratio. If it was a different ratio, it wouldn't be that compound. So, because compounds have a definite ratio, then that is why they are identified as a pure substance. So table salt is a compound that contains the elements sodium and chlorine. And what's really weird is that sodium is a metal that's actually very reactive, whereas chlorine gas is a green poisonous gas. But when you combine them together, they make something totally different that I love putting on my food. Well, some of my food anyway. Now then, let's talk about mixtures. A mixture is a type of matter that consists of two or more substances that are physically mixed but not chemically combined. Two or more substances in different proportions that can be separated by physical methods. So an example here is a mixture of spaghetti and water is separated by using a strainer, a physical method of separation. So when you had the spaghetti and the water, that would be a mixture because you had both water and spaghetti and you could separate them. Now in a laboratory, they're going to have a little bit better straining methods there. Okay. But so on the first side, a mixture of liquid and solid is separated by filtration. They just filter it there. And B, different substances are separated as they travel up different rates up the surface of chromatography paper. And so we're going to actually be doing a chromatography lab later in the semester. But anyway, these are different examples of separation of mixtures. Now then, let's talk about homogeneous mixtures. The composition is uniform throughout the sample. The different parts of the mixture are not visible, and I think I had mentioned that. So if I look at this brass musical instrument here, it all looks one color. It doesn't look like, oh, copper and zinc together. Now then, if any of you have gone scuba diving, you know that the different tanks that you have different mixtures. So breathing mixtures for scuba are homogeneous mixtures. Some examples are nitrox, heliox, and trimix. Now in a heterogeneous mixture, we can see the differences, and the composition varies from one part of the mixture to the other. It's visible. So let's identify each of the following as a pure substance or a mixture. Well, pasta and tomato sauce. I can see two different things. So that would be a mixture. Aluminum foil, well, you just see the aluminum foil. That's going to be a pure substance. Helium, well, that's a pure substance. Now, air, depending on where you're at, your air is going to have different mixtures. So it's not all going to be the same. So that would be classified as a mixture. So now then, you do this, and you put it on pause and see if you can do this. Hot fudge sundae. You look at that, and yeah, you got the ice cream that's white, and you got the hot fudge that's chocolate. Okay, that is heterogeneous. Baby shampoo. Well, the baby shampoo all looks the same when you're pouring it out of the bottle. So looking the same, that's your clue, homogeneous. Sugar water. Well, that's just water that's got sugar in it that's stirred, and so it looks all the same. It's uniform, so that would be homogeneous. Whereas peach pie, I'm assuming you know that you got the crust, you got the peaches, you got the yummy stuff in there, so that would be a heterogeneous solution.